Today, we're going to break down the math behind predictable patterns. And look, this isn't just about numbers on a page. It's about a seriously powerful way to forecast things, from your future salary to how your savings might grow. So let's dive in and see how a couple of simple formulas can help you predict the future. So let's kick things off with a question that probably feels pretty familiar. You get a new job, starting at 22 grand a year. And the deal is, you get a $500 raise every single year, like clockwork. The question is, what will you be making in your 7th year on the job? I mean, you could write it all out, but there's a much faster way.
If we just map out the first few years, you can see the pattern plain as day. Year 1, you're at 22,000. Year 2, add that $500, you're at 22,500. Year 3, another 500, now you're at 23,000. It's this steady, predictable step up, each and every time.
Now, this kind of step-by-step growth, it actually has a special name in math, and it is the foundation for everything we're about to get into.
It's called an arithmetic sequence, and all that fancy definition really means is exactly what we just saw with the salary. The big idea is super simple. You start with a number, and then you just add the exact same amount over and over again to get the next number in the line.
And that fixed amount, the one you keep adding, it has a name. It's called the common difference, and we just use the letter D to represent it. Honestly, the best way to think about it is just as the step size for your pattern. So in our salary example, the step size, D, is that $500 raise.
Okay, so we've got a name for the pattern, but how does that help us find our salary in year 7 without having to count out every single year? Well, this is where we get our first really powerful tool, a formula made for this exact situation.
And here it is. This little formula is the key to finding any value in one of these sequences, no matter how far down the line you want to look. I know it looks a little abstract, but let's break down what each piece of this puzzle actually means.
It's actually way simpler than it looks. AN is just our goal, the value we're trying to find. A1 is our starting line, that very first number. N is the position we're interested in, like the 7th year. And D is that step size we were just talking about. That's it.
So let's use it to solve our salary problem. Our first term, A1, is 22,000. The term we want, N, is 7. And our step size, D, is 500. We just plug those numbers in. 22,000 plus 7 minus 1 times 500. That's 22,000 plus 6 times 500, and boom, your 7th year salary is $25,000. No counting required.
Okay, so we know the salary in year 7. Pretty cool. But what if we ask a bigger question? What if you want to know the total amount of cash you've earned over all 7 of those years, combined? Well, now we have a totally different kind of problem, and it's going to need a different kind of tool.
And the story behind this next tool is it's awesome. It's this famous story about a young kid, a genius, who saw a shortcut that nobody else did. So the story goes, you have this grade school teacher who just wants to keep his class quiet for a while. So he gives them what he thinks is a super time-consuming, boring task. The assignment was simple. Add up every single whole number from 1 to 100. 1 plus 2 plus 3 plus 4, all the way to 100. Just imagine doing that. It should take a long time, right?
Well, not for one kid. A young Carl Friedrich Gauss, who would grow up to be one of the greatest mathematicians ever, supposedly solved it almost instantly. The answer? 5,050.
But how? How did he do that so fast? It wasn't magic. It was just this brilliantly simple insight into how these patterns work.
So let's take a look at the genius behind his method. This brings us to our second big idea, how to find the total sum of a sequence.
Okay, check this out. This is Gauss's logic. Forget 1 to 100 for a sec. Let's use this simpler example of adding even numbers from 2 to 54. You write the list out. Then right underneath it, you write the same list, but backwards. Now here comes the magic. Look what happens when you add the numbers vertically. 2 plus 54 is 56. 4 plus 52 is 56. 6 plus 50 is 56. Every single pair adds up to the exact same number. Incredible. What we're doing when we add up all those numbers is called an arithmetic series. It's a really simple concept. If the sequence is the list of numbers, the series is just the sum of everything on that list.
And that brilliant little pairing trick from Gauss gives us our second formula. The total sum, Sn, is just the number of items you have, n, divided by 2, times the first number plus the last number. That's it! It's such an elegant shortcut.
So let's go back and solve our total salary problem. We've got 7 years, so n is 7. The first term, A1, is 22,000. And we already figured out our last term, A7, is 25,000. So we plug it in. 7 divided by 2 times the sum of 22,000 and 25,000. That gets us 3.5 times 47,000 for a grand total of $164,500 earned over 7 years.
And these formulas aren't just for abstract problems. They are incredibly useful for making sense of patterns that pop up all over the place in real life. Let's take a look at one more practical example.
Here's where we can see these two formulas working together as a team. Imagine a contractor is facing a late penalty. It's $500 on day 1, and it goes up by $100 every single day. To figure out the total penalty after 10 days, we need 2 steps. First, we use our sequence formula to figure out the penalty on that very last day, day 10, which works out to $1,400. Then, we can use our sum formula with the first and last day's penalties to find the grand total, which is a whopping $9,500.
So when you boil it all down, you've now got 2 key tools in your toolkit. The first formula lets you zero in on the value of any single step in a predictable pattern. And the second one lets you add up the whole shebang to find the total sum.
And really, that brings us to the final thought. Now that you can see the math behind all this, where do you see these patterns in your own life? Maybe it's a workout plan where you add a few more reps each week, or a savings goal where you deposit the same extra amount each month. The patterns are literally everywhere, and now you have the tools to actually predict them. Thanks for tuning in.